Different kinds of satellites are there. You can see here there is a equatorial orbit satellite. Equatorial orbit. Normally, almost all communication satellites will be equatorial orbit satellites. That is, it will go through this equatorial orbit. And normally there is a term called as geostationary satellite. Geostationary means while it will, when the Earth is rotating from west to east, you can see that when the Earth is rotating from west to east, along with that the satellite is also moving. So the velocity of rotation of the satellite is equal to the surface velocity of the satellite itself. And normally there will be another orbits also, medium Earth orbits, lower Earth orbits also there. Lower Earth orbits. Geostationary satellite means it is moving at the height of 36,000 kilometers from the surface of the Earth. And again, lower Earth orbit and medium Earth orbit means normally it will be lower than that. So normally to keep it there, to keep that satellite there, normally its velocity will be higher than the rotational speed of the Earth. Otherwise, it will come back to Earth. So normally it will not seems to be stationary. That satellites will be used for meteorological purpose, that kind of things, not for communication. For communication purpose, the satellite seems to be stationary. Then only we can point an antenna directly towards that. Otherwise, we have to always rotate the antenna along with this satellite. Then another orbits are there. Inclined orbit is there. Again, polar orbit is also there. Polar orbit is moving from it is moving through these polar regions of the satellite. All these satellites cannot be used for communication purpose, but it may be used for your meteorological purpose. Satellite is moving in a circular fashion in the geostationary orbit or medium Earth orbit or lower Earth orbit. So it is based on the movement of the satellite in this orbit is based on the centrifugal balancing of centrifugal force with the centrifugal force means it is in this direction, in the direction of motion, and centripetal force plus acceleration due to gravity. So normally there will be an acceleration due to gravity. So that is because of that acceleration due to gravity, there is a chance to pull it towards the center of the Earth, and there will be a centrifugal force that is equal to mv square by r. M is the mass of the satellite, v is the velocity, and r is the radius. Mv square by r. Mv square. So when these forces balances, the satellite will be in the orbit itself. So as the satellite orbit comes down, when it is in the medium Earth orbit, the acceleration due to gravity will be higher. So to overcome the acceleration due to gravity, it has to move at a greater speed. And when it is at lower Earth orbit, it has to move at a somewhat higher speed than medium Earth orbit as well as geostationary orbit. So it will not be seems to be stationary in the lower Earth orbit and medium Earth orbits. Whether in the medium Earth orbit or in the lower Earth orbit or in the geostationary orbit, the laws of motion of satellite is governed by Kepler's law. So I think you might have studied these laws in the plus 2 classes. So Kepler's first law states that the motion of a satellite around the Earth will be in an elliptical orbit, and the Earth will be in one of the foci. And the second law states that the satellite sweeps equal area in equal interval of time. Equal area in equal interval of time means that here this is the S2 is an area, S1 is another area. So here S1 is equal to S2. S1 is equal to S2 means here here the satellite is far away from the earth. Satellite is far away from the earth means to make this area equal to this area, here the satellite will be, the movement of satellite will be slower here, and here the movement of the satellite will be higher. That is, you can see that here the satellite speed will be higher, or this is known as the perigee. The speed will be perigee എന്ന് പറയാം. At the perigee the speed will be increases, and apogee the speed will be lower. And the Kepler's third law states that the p square means the period of, that is the p square means the period of revolution around the earth. That is, in this case, it is geostationary, it is 24. In the case of geostationary orbit, p is equal to 24 hours. So p square is proportional to the length of the major axis. This is the major axis. P square is proportional to cube of the major axis. P square is proportional to m cube. Normally, the position of the satellite in the space is specified by the latitude and longitude. Latitude means the distance or the angle traced from the equator to the north or to the south. It is normally towards north it is specified by plus 90 degree, and towards south it is specified by minus 90 degree. Towards south it is plus 90 degree, and towards north it is specified by minus 90 degree. And normally a geostationary satellite will move through this equatorial line. Normally a geostationary satellite will be, so the angle will be 0 degree. The angle in the latitude angle in the equator will be 0 degree. And again, longitude is actually the angle traced from the Greenwich line. That is, the reference is the Greenwich line, and towards west it is measured by plus 180, and towards east it is minus 180 degree. Minus 180 starts from geostationary. So this is the so in that manner we are specifying the position of the satellite in the space. And again, one more thing is there. Normally a polar satellite, this is the directional portion of a polar satellite normally. So there will be, it can have any space in this line, and again the direction of, it can have another motion also, another angle of motion also. And again, there will be inclined orbit satellite also. There will be satellites that is moving the inclined orbit. So normally geostationary satellite will move through the equatorial line only. And here you can see that this is the satellite, and this is the earth station. This is the earth station, and this is the center of the earth. And between the earth station, satellite, and center of the earth, there is an angle. We can draw a triangle, and we can directly draw a local horizontal from the earth station. So that is tangential to the surface of the earth. That is tangential to the surface of the earth. So with respect to the earth, the satellite is specified by another angles. That specification is known as the look angle. So this angle is known as the phi, is known as the elevation angle. Elevation angle means from the horizontal line, how much we have to look up to see the satellite. That is the elevation angle. And there is called as an azimuth angle, elevation and azimuth. Azimuth means the angle traced from the angle we have to look towards left or right, or in the longitude line. That is, with respect to true north, how much we have to turn to look into the satellite. If you are drawing a line with respect to the true north from the earth station, and how much we have to turn, that angle is not here actually. This can be treated as the psi, or that is not that angle. Actually, the psi is actually the 90 degree plus phi, So the azimuth angle is not shown here. This is the azimuth angle is actually the angle that we have to sweep with respect to the true north to see the satellite. So that angles are specified from the earth station to see the satellite. So that is known as the look angle.